Perfect. Okay, so would everybody do me a favor? I have a bunch of stuff up. We've got a dinosaur. We have a Sasquatch guy. And he has a bunch of learn targets, but those are kind of the teacher ones. This one is, why is the scientific method important? Alright? So, I want you guys to turn to your buddies at your table and talk about what that means to you and why you think it's important. And I want everybody to look at your desk. There's a number on your desk, right? Yep. I'm going to pick a table and a number randomly. So just be ready to go because it could be you. 10 seconds. What does this mean? Why is it important? You guys ready? 10, 9, 8, 7, 6, 5, 0. Alright, could I have this table? You guys ready? Yeah? You guys need 5 more seconds? Then quietly figure it out. This table, number...
It's you, dude. It's you.
Convo, it's you. So what did you think? What do you think this means and why is it important?
Scientific method helps us discover or like test out new items.
Test out and discover new items. Yeah, Sophia, back to your table. Okay, track your own experiments and other people can follow it. Okay, back corner table, you guys ready? Dun dun dun, number 5. Who's closest to number 5?
Wow. Okay. So it's the scientific method. It's basically a way that we can figure out new stuff, but we can also see that it's valuable new information, not just doing some random experiment. It kind of works, but like seeing that it does work.
Perfect. I love what you said. Making sure that we find the valuable information. Well, you guys, I have some bad news for y'all. You have a quiz. But it's just a pre-assessment quiz, so you just have to try your best. Would everybody log on to Schoology and go to the science page? Oh. No computer today? Did you drink today? Your computer, Nick? Okay, only... Okay.
So, I drive carpool and I brought my backpack out of the car, and when I got in the car, it was dropped on the sidewalk.
Got it. It's not still on the sidewalk, is it?
No, it's being brought.
Okay, perfect. We'll then work with Mr. Foster doing the right thing. All right, yes, sir. You want to go plug your pen and go get it? Why don't you do that? So if you go to your science course at the very bottom, it says variables assessment. It's 5 questions. Go ahead and get started once you find it. Raise your hand if you have any problems navigating there. Raise your hand if you have any problems navigating there. Yep. Variables quiz. Good job, you guys. I will know when you are done because you'll tilt your screen. Thanks, Cameron. Submit it. Raise your hand if you're still working. Go get it, Kamlu. Alright, while Kanwoo is finishing up, I have a question for you guys. Are you ready? Okay. I'll wait till you guys are looking up here. Perfect. Sophia said something this morning that I thought was really interesting. She said it's important to have the scientific method because we need to have steps that other people can follow. We need to have steps that other people can follow. What does that mean to you? We need to have steps that other people can follow. Leah.
So like it means that, for me at least, so like if you're like making steps out to do something, you want to be clear and not just be like if you were like baking cookies in the oven and bake. For how long? What degree? I don't know, my mind immediately goes to cookies.
I love that. And you don't want to burn cookies, right?
Yeah.
So good job. Otto.
To have a standard method, so that everybody can understand it instead of just a random blur of numbers and words.
Yeah. To have a standard method so it's not a blur of numbers. Yep, Gabriel.
Just so that way they're able to test it themselves so they know it wasn't just random trend.
Yeah, you want things to not be a fluke. You want it to be very dependable. Yeah.
It has to be recreatable just by somebody else, so it has to be very specific, and we have to know what you're doing to get the same results.
Okay. Reproducible data is really important. But here is my question. Can your table brainstorm one scenario where you need to be able to reproduce your data, your thoughts, every single time? Did that question make sense?
No.
Can you think of a time in the real world where you have to be able to follow the scientific method and have the exact same outcome happen every single time? Where you don't want to leave it up to chance. You want to make sure that you get the exact same outcome. So talk at your table for how about 15 seconds this time? 15,
Oh, no. That can be up to chance. The length of a ruler is a perfect example. You can't really change
6,
that.
yeah, 5, 4,
Check what's your
3, 2, 1, 0. Done. Okay.
I'm done.
Is Daniela's table ready? Do you know what your number is? Because I want to know from number 5. Because you're number 5. So Janasa, what did your group come up with?
So, we're talking about why it's important, right?
Yeah, why do you need to have the outcomes always be the same using the scientific method?
It's not the same because following the same steps each time.
Yeah, but what's a specific real-world scenario
Oh,
that your group
real
came up
world.
with? Yeah, sorry.
Like, you think the cookies?
Yeah, that totally was an idea from earlier. What did your table come up with?
We came up with cookies
Yeah.
and building skyscrapers.
Building skyscrapers, awesome. All right, your table. Are you ready? Number 6. Who's closest? Oh, hold on. I can't hear her thoughts. Go ahead. If you're making medicine or if you have a surgery, how many of you guys, when you take medicine, you want it to be reliable 100% of the time? How many of you guys want it to be reliable 60% of the time?
It's better than 0, so yeah.
Okay, that's very true. But if you had a choice between 100% and 60%,
110%.
110%. Okay. Did I have any other thoughts that we did not get called on? Yeah, Fiona.
Testing the airbags on the cars.
Testing airbags on cars. Amazing. Yeah.
Coding
Coding for
for anything electronic.
anything electronic. Yeah, Molly.
Like testing the material for hot air balloons.
Testing materials for hot air balloons. Ronnie, did you have an idea? Okay. Fiona. I just did that again for the second time. Candy. I owe you candy now. Okay, and I have candy. So Candy, go ahead.
Factories.
Factories. Yes, is.
Specifically meat factories.
Specifically meat factories.
But it has to be the same temperature and it has to be the same size.
You want that meat to be preserved in a consistent way.
Meatball size.
This just took a weird turn, but okay. Kangaroo.
Specifically scrambled eggs.
Specifically scrambled eggs. You want your normal scrambled eggs. Okay, we're getting goofy. I'm going to take 3, 2, 1, and then we're going to move on. Okay, go ahead.
You have to be really specific when you're measuring the ruler.
Measuring a ruler. You can't mismeasure a ruler.
I know, but that's exactly why when you're making the ruler, you have to get it 12 inches. Cause well, no, like
You could really mess with someone's
you
life,
could
right?
really- yeah, like
Yeah.
they could be measuring the size of a pig's tail, and it's like vital information for scientific study. And then it's like the ruler's off like a fraction of an inch, and they're like, oh no.
Can I ask you one
I
question?
feel like they use rulers
How
for
many
that,
times have you had to measure a pig's tail?
Like 3 times.
3 times in one? Okay, so we need to be very consistent. Yeah, Mr. Sheets, you were our second one.
Yeah, it's like
So serious.
Oh, yes, so the guy who skydove without a parachute and then he jumped in the net? Absolutely. And then I had one last thought.
It was me.
Go ahead.
Making airplanes.
Making airplanes, because I want my airplane to be pretty light.
I do.
Okay.
I do.
Everybody please untilt your screens. We are going back to OneNote. You're done with Schoology, so if you want to close that out, that's totally fine. We are not going to be in meteorology today. Alright? We're going to the scientific method. We are going to the scientific method. Can I have a thumbs up when you've made it there? Rad. Okay, so, do you guys know any of the background of the scientific method? I know some teachers in Quest do it, some teachers don't. Does anybody know how it all got started?
No.
Shanasi, you have an idea?
Nicholas Copernicus.
Very close. That was some good investigative skills. Yeah, Brian.
I know Isaac Newton not only used it a lot, but he kind of invented it.
Yeah, he played a huge role in it. Come on.
Someone that wanted to prove something.
Someone who had something to prove. A scientist on the streets.
Galileo.
Wanted to make his data reliable. Yeah, Cameron.
What about that guy whose last name was Bacon?
Francis
Bacon.
Bacon! Francis
He
Bacon!
was a big deal. Okay, so I see some of you found my pictures on OneNote. Cool.
Oh, what the?
Alright, before these guys, people were doing science. They really were. It just very much was not reliable. Alright? People were doing things on a hunch. They were keeping things very secretive. They also had some pseudoscience in there, like alchemy. They're like, hey, this bar of lead, I bet it could be gold someday. So they were really trying a bunch of random stuff. But the first guy who made a really big impact on the scientific method is, what did you say his name was, Shanasa?
Nicholas Copernicus.
Well, it is Nicholas Copernicus. Does anybody know what his claim to fame is? There, I don't see a hint in his picture. Anybody? I see hands, but I'm looking for someone I haven't called on today. Yeah, Rodney, I haven't technically called on you.
He tried to prove that the Earth was around, not flat.
He did have a part in that, but it was a bigger picture than just looking at the Earth. Molly.
Oh, did it have to do with astronomy?
It had a lot to do with astronomy. Yep. Do you want to go around two?
Yes, he proved that the sun didn't revolve around the earth, that the earth revolved around the sun.
That's exactly it. This guy, in a time when it was not cool, said, our planet spins around the sun. The sun doesn't spin around us. And that was a really big deal. And Rodney, the reason it was a big deal is because he observed it. Before that, people would kind of have an idea and try to go out and prove their idea. He went the other way around. He saw things, he just took notes. And after he observed as much as he could, then he drew a conclusion. That brings in the bacon guy. Cameron, is that your guy? Yeah. The bacon guy. The bacon guy said, Copernicus, that's where it's at. He didn't go out there and prove anything. He observed as much as he can, and I want to make science observation-based, not make it happen-based. So that is why Sir Francis Bacon, that's what he really contributed. And then we get to my hero, Sir Isaac Newton. What did, yeah, go ahead.
He was a physicist.
He was a physicist, and he even invented calculus. No, he did not invent the apple. Yeah, Kanu.
Did you know, thanks to one of his equations, we found out that there was Neptune in our solar system?
Yeah, because Neptune was one of the planets that was discovered through math, right?
Yeah.
Absolutely. All right, did you guys have a thought? Not quite? All right. I'm going to have you guys pause for a second. Apple. They think at this point the apple thing might be a myth, guys. Are you guys okay? Just check in. Okay. So the apple thing might be a myth, but he did observe that things fell. Before him, things fell. And people were like, oh cool. We've got falling stuff everywhere. There's leaves, snow is falling, rain is falling, I'm falling down the hill. But no one really knew how or why. And he kind of conceptualized gravity. He was a pioneer in light and optics, and like I said, he invented calculus. He did this all, a lot of it, over one summer break. Think about that. That's pretty crazy. But despite all of his amazing things and being one of my heroes, he also formalized the scientific method. Because we need medicine to be consistent every time, he came up with this system where he was like, okay, everybody on the planet needs to be able to follow these steps. Because medicine is not for me, it's for everybody. When I fly in an airplane, I want to make sure that it has the best odds every time. Because nobody wants to be in a 50-50 plane, right?
No, I had to do that across the Atlantic Ocean.
Seriously?
Yeah.
You're my hero. That's pretty amazing.
I thought you
Was it scary?
Yeah.
Well, I'm proud of you.
7 hours.
Yeah.
I thought your hero was Sir Isaac Newton. That's what I just
Okay,
said.
well, I have double heroes today. Is that okay?
Yes.
Okay, so we are going to this year be very much exploring all of the parts of the scientific method because our 8th grade teachers expect that you guys can participate in all of that. And Callis has a really consistent way that we present the scientific method. Have you guys noticed Sir Isaac Newton up there with his tacos? Okay, well, that is part of Callis' scientific method, but to participate in that, you guys need to know your variables. Okay, so we are going to do that. Do you guys see up here that underneath it says, welcome to the scientific method? It has vocabulary.
Yes.
Okay, so Mr. Haynes is going to be writing in that. You guys cannot edit this page, but when I'm all done, can you copy and paste it and put it in your own OneNote?
Yes.
Absolutely. So you can either track me on your sheet, on your computers, or you can watch up here. All right? So I have a question for y'all. How many of you guys have ever heard of the word variables? Raise your hands. 4, 8.
Basically.
Okay. I got 33. Any of you guys not heard of it? You guys are pros. So I have 33 of you guys that have heard of it. But my question is, what does it mean to you? So anybody brave enough to tell me what you think the word variable means? Shay.
Something in a process that contributes to something else. Like,
That can change.
an example would be,
Something in a process that what?
that contributes to the experiment.
To an experiment. Cool. Alrighty, Mr. Sheets.
Like the changing factor in the process.
Changing factor in a process. Alright. How about any other thoughts? Yeah.
It's something that can change.
Something that can change. Bryson?
A factor in a process.
A factor. How about Sammy, was your hand up?
Yeah, I was just gonna say, well, variables is a word that's used to describe any object that can be used.
A word to describe, what was that? How do you phrase it?
Any object that could be used.
Any object that could be used. Okay. Alright, next big word. You ready? Manipulated. How many of you guys have heard that? I am going to do this the easy way. How many have not heard of it? Cool, I'll give you guys a 33 and 0 again. What does this word mean to you guys? Yeah.
The variable in an experiment that's changed.
Okay. I am finding right now that you guys seem to know this vocabulary. Yes. So how many of you guys feel like your 6th grade teacher did a good job going over these terms? Shout out to your 3rd grade teacher then.
Yes.
Our 6th grade teacher
Hey guys. That's a really good question. How many of you guys attribute knowing these vocabulary words to the science fair last year?
Oh,
Good. I do remember you from last year.
How to change my order.
I am still sorry about that, Kevin, but it wasn't me. I do, but I also taught you over. Hey, you guys. We've been in class since December. I know all these things. Here is my question. What?
You said we've been in class since December.
Okay, I made a mistake. But look up here. How many of you guys feel confident in all 4 of these words? How many of you do not feel confident in all 4 of those words? Alright, so let's change the format a little bit then. Okay? Let's put our definitive meaning in. So, I think this second sentence right here, a changing factor in a process, is a really good way of describing variables. I love that. Was that you, Mr. Sheets? I think that was brilliant. Mr. Foster?
Could it also be something that is liable to change?
Yep. Which is, did you say liable?
Yeah.
Okay. Can I change your word a little bit?
Yeah.
Which could possibly change? Is that okay?
Yep.
Alright. What is, yeah, Brian.
If we did it with the second part, wouldn't we have to take out the first changing? So it would just be a factor in a process, which is liable to change.
I love that you are better at English than I am. Sure. That grammatically seems great. Alright. Next big word is manipulated variables. So, what is your guys' takeaway since you guys are pretty confident in these words? What do you think a manipulated variable is? Yeah, you did, but I just want to say it again for the official definition. Yeah.
A variable that you change in.
Okay. It is the variable that you change. Alright? Then, Robbie, do you have one for responding, bud?
Some trouble between responding and control.
So is it good that we're going over it right now?
A little bit, yeah.
Cool. So, what does the word responding mean? Wait till I call on you, bud. Thank you, though. How about this? Robbie, I want to talk to you again. Would it help if you talk to your table for a couple seconds?
Okay.
Cool. All right, talk to your tables. What does responding mean?
No, there's
Alright, Robbie, I said I would chat with you again, bud. Did your group help you clear it up, or can someone at your table help Robbie out?
Okay, well, the responding variable would be the variable that changes after you manipulate the other variable.
That is 100% accurate, but I think that Mr. Haynes' definition is a little easier to track. So let's see if someone else has a way that your maybe your third grade teacher, your sixth grade teacher taught you. Luke?
The variable that reacts to, or the responding variable is a variable that reacts to manipulated in.
Yeah, so I do something, and this reacts to it. Go ahead, Fiona.
Can I provide an example?
I'd love you to provide an example.
So I'd like to think of the manipulated variable as like the x-axis
Uh-huh.
on a graph, and the responding variable is the y-axis because x-axis is independent.
Who's your math teacher? She's killing it. Good job, Fiona. All right, I'll take two more thoughts, and then I'm going to jump in with mine.
The responding variable is a variable that you extract your information from.
Yep, absolutely. Go ahead.
Variable that you record.
Very good, but we should be recording a lot of variables. Okay,
You're writing down what you're doing just so it can be recreatable, but you're recording your data that you're getting from your experience.
Can I simplify it a little bit?
Yes, a lot.
It is the one you measured. You guys knew it. Right? You guys said it in very big words, but that might be a little bit easier. Okay, and then the control variable is the one that you try to keep. What was that, Daniela? The same. So, why is a control? Okay. I hear a lot of the side talk. Can I have you guys focus back up here?
Yes.
Thank you. Why would one you keep the same? Why would that be important? Why would we want to keep one idea the same? No offense, y'all. Oh, I was gonna say, I see all the same hands. Go ahead. Yeah, if you are doing an experiment and two things are constantly changing, which one actually made the amazing thing happen? So that makes it hard to track. Go ahead, Ronnie.
I was gonna say that it'd be totally randomized. It'd just be a random plot of different things.
A random, yep, you don't want it to be that way, right? So by having it be one, you can see a correlation. Go ahead, Mr. Sheets.
Well, if you like change the, like, if you change the control variables, then it would be like a totally different experience.
Yes. So, did I tell you guys that I did something sneaky this morning and signed you all up for choir?
You're lying.
Because everybody's gonna sing right now.
Yay!
No. Yeah. Totally are. Okay. But, Robbie, chill out. But, you guys want to do the water cycle?
No!
Okay. 3, 2, 1. The back table ones do the water cycle, maybe at the end of the period. This one's different. And this one's easy. I sing 99% of the time, you sing once. Okay? Well, and by once I mean one word at a time. So I will say, you guys ready? Look up. Trevor, look up. Alright, I say, manipulated are the ones you, and what do you do to a manipulated variable? Change. Manipulated are the ones you change. Okay, good. You're already acquired. And responding ones you. There you go. If you get it wrong, you'll feel displeasure. And controls are the ones you keep the same. Oh my gosh. So, are you ready?
Yeah.
Are you ready?
Okay, whatever.
Okay. I wish I had like one of those batons. You ready? I'll wait till you get quiet, and then we'll get started. Okay. Manipulated are the ones you change. Manipulated are the ones you change. And responding ones you get it wrong, you'll feel displeasure. And control are the ones you keep the same. That was a really good harmony. Give yourselves a round of applause. Very good. All right. So what's happening now is we are going to start looking at them in real scientific scenarios. So if you guys navigate to your homework tab, Brian yelled at me earlier because he's like, you gave me homework. Yeah, I assigned you homework. But we're going to look at the first part together. So would you guys flip over to the homework tab? It should already be there for you. And it says controls and variable. And if you're in the right spot, you should see halfway down the page the Krusty Krab. Okay. Yes, ma'am. Oh no. Jalen, can you catch? She was in volleyball. She's got this. Okay. So we have this assignment that, yes, you are working on today. So, first things first, you don't have to write out the entire definition, but I do want you to write the keywords. So it says, write a definition for each of the following words in your own words. So would you guys write down what you guys think for control, variable, manipulated, and responding? And if you guys want to go back and look at Mr. Haynes' definition that you guys came up with the class, all you need to do is navigate back and forth. Yeah, Robbie?
We can't find the,
Did it not distribute?
Yeah, I don't have it.
Okay. Whoa, some of you do, some of you don't, but we know where to look. We know where to look, right? Where does Mr. Haynes keep his handouts? In the content library. So look in the content library, controls and variables, the very bottom line. And then you have to right click it though and put it in your homework. Remember you have to copy and paste it into your homework. Alright, perfect. Alright, so everyone should be writing their own vocabulary definitions right now. You can't use the one I did. I said that was fine, but you're still writing it down. That way you have it in your memory. I can't hear you. Yeah, it does. Sorry, thank you. Good clarification. Oh, you're skipping work.
Yes.
Beast. Beast.
Yes, it is my job.
Good job.
I literally get paid if I get these.
What?
By my parents.
You are so lucky.
I don't even
Do you have straight A's then? It's like the original scholarship.
I would be rich if it was fun. You're just like,
Shailen, you doing okay?
what's our Hey, camera.
SpongeBob clean pants.
Because I don't want Lucas to be the only person. Okay, I saw a lot of definitions. I just want to go over the first scenario with you guys, and then let you guys practice on your own. Okay? Sound good?
No.
Stop yelling at me, Molly. Oh. Okay, so who wants to read the scenario to Mr. Angel and Mr. Krabs? I expect it to be done in a theatric voice. I love how calmly Jaylene raised her hand. Go ahead. Okay.
Mr. Krabs created a secret ingredient for the breakfast that he thinks will cure the bad breath people get from eating Krabby Patties at the Krusty Krab. He asked 100 customers with a history of bad breath to try his new breath mint. He had 50 customers, group A, eat a breath mint after they finished eating a Krabby Patty. The other 50 customers, group B, also received a breath mint after they finished the sandwich. However, it was just regular breath mint and did not have the secret ingredient. Both groups were told after that they were getting the breath mint that would cure their bad breath. 2 hours after eating the Krabby Patty, 30 customers in Group A and 10 customers in Group B report having better breath than they normally had after eating the Krabby Patties.
Dude, that commitment, everyone round of applause. That was beautiful. Alright, so I'm going to skip number 1 and go back to that because my first question actually is, what did Mr. Krabs change? What did he do? He's like, hey guys, you don't know it, but I'm changing something big. What am I changing? What am I changing is the types of breath mints. So you guys could write that down for number 2. Then the responding one, you. Oh, good job, because I went out of order that time. The responding one, you.
Measure.
So what did he measure? Because he measured something. He measured something. I'm just letting people think. Can I ask you one more question before I actually answer that one? How many of you guys are just working on the assignment right now? Looks like some of you are. That's totally cool. All right. So what did he measure, Cammy?
He measured how better how much their breath smelled better.
Yeah, he measured how much they thought their breath smelled better. Yes? He actually measured the customers whose breath was better. Nick?
He measured the amount of people in each group who noted a difference in their breath after Krabby Patty and taking it.
So the customers who noticed improved breath. I think that took all of our ideas and made them one solid one. So if you want to write that in, last but not least, what is something he kept the same? What is something he kept the same? This is my favorite variable because you can always think of a million different things. There's a ton of things kept the same. Yeah, Fritz.
The type of breath mint?
The type of breath mint, go ahead, is the food that you eat beforehand. Yep. The amount of people in his total group running.
When they took the breath mint.
Yeah, because they took it after the meal, that made a big deal. So when they took it, go ahead, Nick.
The Krabby Patties that they ate were prepared and had the same stuff on them.
Yeah, the Krabby Patties all had the same thing because that'd be really unfair if like some got onions and others did not, right? Last one.
Both conclusions were reported 2 hours after eating the Krabby Patty.
Yeah, so they had to wait 2 hours after. Perfect. Okay, so here's what I would like. I would like for you guys, we have about 6 minutes left. I want you to try to finish the first page, because we can always come back to it later this week, but I want you to at least get a little bit of practice on your own. I'm going to wander around. On your mark, get set. What?
Is this homework?
Nope, it's not homework. You can work together. Hey, Mr. Kovacs. On your mark, get set, go.
Okay.
And I'm going to come and answer your question, friend. What? Just finish the first page. Okay? So there's a couple more like comprehension type questions.
What do you think Mr. Krabs' conclusion should be? Always give the customer's preference. Regular mix. The secret ingredient of the egg.
Okay? Cody, okay?
Okay. Why examples details of sport why you think in number one what Mr. Krabs
See what it is in the corner next to the hand sanitizer? How are you guys doing? Yeah. Do I spell it wrong? I did? On here. Did I really? I'm a horrible speller. I apologize. Spell check should have got that. No way, Jose Molly. No way, Jose. Molly. You're so extra today. Are you guys doing okay? Good. What's up, Luke? What's up, Fritz? If you want to, yeah. If you want to get ahead. Absolutely. No, we'll finish it later this week. Yeah.
What time will we get out?
Which is the one that they kept the same without new changes?
Oh, yes.
Sounds like you have your answer. Which group was it to you? Tell me the difference between each group.
Group B is the base that Photoshop.
So yeah, it would be group B with the baseline, no new ingredients. Right, but one was given the old type, right? So that's not the new change. The science didn't change anything in that one. Yeah.
He's so proud of himself.
You know what? Knowing Mr. Krabs, I think he's totally he's down. Someone did the math.
It turns out.
You remember that?
5 minutes after.
No. Okay.